Today, I am going to show you the proof of the constant multiple rule of differentiation. Now let's solve the constant multiple rule. It is stated that the derivative of c times f of x is equal to c times the derivative of f of x. In order for us to prove the derivative of the constant multiple, we will use the limit definition formula of derivative, which is the derivative of f of x is equal to limit of f of x plus h minus f of x all over h as h approaches to 0. Suppose we have y is equal to c times f of x. We just need to substitute the value of y to the limit definition formula of derivative. Now it becomes the derivative of c times f of x is equal to the limit of c times f of x plus h minus c times f of x all over h as h approaches to 0. As we can see that the c or the constant can be factored out. Now it becomes the limit of c times f of x plus h minus f of x all over h as h approaches to 0. As we all know that the limit of constant is the constant itself. Now it becomes c or the constant times the limit of f of x plus h minus f of x all over h as h approaches to 0. The limit of f of x plus h minus f of x all over h as h approaches to 0 is just the derivative of f of x. Therefore, that the derivative of c of f of x is equal to c times the derivative of f of x. Let me give you an example. Let's recall the constant multiple rule. The derivative of a constant times the function of x is equal to the constant times the derivative of the function. All we need to do is to find the derivative of the function and multiply it to the constant. Let's say if we want to differentiate 8x squared. Now the constant is 8 and the function of x is x squared. Now we can differentiate x squared using the power rule. So let's write the constant 8 and let's take the derivative of x squared. If we will recall, the derivative of variable raised to a constant is n times x raised to n minus 1. So that it will be 2x raised to 2 minus 1. Now 2 minus 1 is 1. So the derivative of x squared is 2x. Now let's multiply the constant 8 to the derivative of f of x, which is 2x. It is equal to 16x. Therefore, the derivative of 8x squared is equal to 16x. Let's see if 16x is also the answer we will gonna get if we will gonna use the limit definition formula of derivative. Let's recall the limit definition formula of derivative. It is stated that the limit of f of x plus h minus f of x all over h as h approaches to 0. Let's consider that we have also the value of y, which 8x squared, and all we need to do is substitute the value of y to the limit definition formula of derivative. It becomes now the derivative of 8x squared is equal to the limit of 8 times h is equal to the limit 8 times x plus h squared minus 8x squared all over h as h approaches to 0. As we can see that the constant 8 can be factored out. Now it becomes the limit of 8 times x plus h squared minus x squared all over h as h approaches to 0. It says that the limit of a constant is a constant itself. So we can separate the constant 8, the limit. It will become now 8 times the limit of x plus h squared minus x squared all over h as h approaches 0. Now let's find the square root of x plus h, which equal to x squared plus 2xh plus h squared. Now let's write 8 times the limit of x squared plus 2xh plus h squared minus x squared all over h as h approaches 0. As we can see that the positive x squared and the negative x squared will become equal to 0. So let's cancel it. And the numerator h, the denominator h, let's cancel it. Now 2x plus h only remain. So the limit of 8 times the limit of 2x plus h as h approaches 0. So let's substitute 0 to the h. So it will become now 2x. Now let's multiply the constant 8 to 2x. It will become now 16x. Therefore, the derivative of 8x squared is equal to 16x. As we can see that 16x is also the answer we got on the constant multiple rule of derivative. Now, it is already proven that the constant multiple rule is equal to the limit definition formula of derivative. And the constant multiple rule is much easier than the limit definition formula of derivative. Therefore, that the constant multiple rule is equal to the limit definition formula of derivative.